Hello, welcome to another episode of Miss Choi's Math. Today in this video, I'm going to talk a little bit about proportional relationships, which is just another way of saying if you multiply one thing by two, you need to multiply the other thing by two. So for example, if you buy twice as many bags of potatoes, you should probably pay twice as much. Or if you buy 3 times as many potatoes, you should pay 3 times as much. Same thing with buying tickets at an amusement park. So if you want to ride, for example, one ride and it takes 4 tickets, and you want to ride 3 rides, that's 3 times as many. So you need to buy 3 times as many tickets. It's basically what proportional relationships are. But we can show proportional relationships in a few different ways. We can use words or numbers like this. We can also use tables and graphs. Okay, so I'm going to go over a few examples using Delta Math here. You can see I have a bunch of graphs, 4 different graphs. And this question is asking which graph represents a proportional relationship. And for proportional relationships in graphs, 3 things must be true. 3 things. Proportional relationship graphs. First thing is you must have a straight line. That has to be straight, completely straight, or a constant rate of change. The second thing is that the line must go upwards. So going from left to right, it has to go up. The more potatoes you buy, the more money you should pay, right? So it should go up together. And the last thing is that the line must start at the origin, or in other words, 0, 0. And the origin is going to be where the 2 axes meet. So right here, in the middle, right there. These are the origins. And the reasoning for that is because if you buy 0 potatoes, you're going to pay $0. If you don't ride any rides, you don't need any tickets. So that's why the line must go through 0, 0. And if you look at this example, you can see that only one of these fulfills all 3 criteria. And that would be letter A. Because it's a straight line, it goes up and it goes through the origin. B is not a proportional relationship because it's not straight. It doesn't go up and it doesn't go through the origin. So that doesn't make sense. C doesn't work either because, okay, it does go through the origin, it does go up, but it is not a straight line. C is not a straight line. And D is a straight line. It does go up, but it does not go through the origin. So D is not proportional either. So E is my choice here. Say yes. All right, let's try another example. This time I want to look for a table. Here we go. Sometimes you can show proportional relationships as tables as well. With tables, you just need to make sure that the unit rate is constant. Unit rate must stay constant. That basically means if you buy 1 bag of potatoes for $3, the second bag of potatoes should also be $3. It has to be the same price for each additional unit, okay? And if you're given a table, the easiest way to do it is to simply just divide. So you're going to divide y by x to equal the unit rate. I'll go over some of these. So for A, let's do that one first. If I wanted to test this one, what I would do is divide the y value, which is 57, divided by 10, which is the x value, and I will get 5.7. 5.7. And what I want to do is test the next one. So if I divide 123 by 21, I'm just going to use a calculator over here. 123 divided by 21. That will be 5.8 and some change. So 5.857. which is not the same. So these two unit rates are not the same. So this must mean that this is not a proportional relationship. You must have the same unit rate for each one, right? So I'm going to skip ahead and I'll test, let's see, I'll test D because I already know that's the answer. I just want to prove a point. So if I divide 6 by 2, 6 divided by 2, I will get 3. If I divide 12 by 4, I will also get 3. So far, so good. The 3 is the same for both. The unit rate is the same for both. And then if I divide, I'm just going to type it out here. It's faster. If I divide 27 by 9, I will also get 3. And for the last one, if I divide 63 by 21, I will get 3 as well. So in this case, the unit rate stayed the same, 3 for each time. So D will be my proportional relationship. So using a table, that's basically it. You just have to divide the Y value by the X values, make sure that that ratio or that unit rate is the same each time. D will be my answer. Yep. I do want to go over one word problem though. So if I go back to the skills, let's see, proportional relationships. There we go. That's a good one. When you're dealing with proportional word problems, it pretty much has to come down to the unit rate again. Remember, unit rate is just how much money are you earning per 1 hour? How much does it cost for 1 potato? How many miles can you go on 1 gallon? The unit rate is basically the product of one variable per 1 unit of another. And that'll make more sense once I go over this example. So if Morgan is earning $283.90 at her job when she worked for 17 hours. So this is our first scenario. We want to figure out how much can she earn if she works for 20 hours. So the first thing to do is to find the unit rate. How much is she getting paid per hour? And how you're going to do that is you just divide the total amount of money that she earned by the 17 hours, which is the total time that she worked for. And if you divide those, oops, you get 16.7. So this is how much she is earning per 1 hour. She's earning $16.70 for every 1 hour that she works. So if she works for 20 hours, right, that's the second situation. What do we have to do? We have to multiply. We're going to multiply this times 20. It's like if she works 1 hour, she earns this much, and she has 20 of those hours, then you need to multiply the amount of money she earned 20 times, right? So we'll do $16.70 times 20. Which is $334. So she will earn $334. And it all really comes down to the unit rate. That's what you would have to do first for these types of problems. Find the unit rate, which is this. Okay, so let's just type that in, confirm that that's correct. And sure enough, it is. So hopefully this video has been helpful for you to understand how to represent proportional relationships as graphs, as tables, and as word problems. Hopefully it's been helpful, and I'll see you on the next one. Peace.